Okay, sketch the graph, this is example 4. So first step, y-intercept. F of 0 equals put in a 0 here and here. What do you get? 2 times negative 9, negative 18, and over negative 4. That should be 4.5 positive. Try it. 2 times negative 9 divided by negative 4. 4.5. 1, 2, 3, 4. Ooh, that one's way up there. Okay, how about the zeros of the numerator? Right? The zeros of the numerator are the zeros of the function. So 2 times x squared minus 9 equals 0. X squared minus 9 is x plus 3 times x minus 3. So what are the zeros? 3 and negative 3. Right? So your zeros are 3 and negative 3. Okay, vertical asymptotes would be the zeros of the denominator. Okay, x squared minus 4, what are the zeros? 2 and negative 2, right? Again, the zeros of the denominator, x squared minus 4 equals 0. That's x plus 2 times x minus 2. So that's here and here. So let me draw a vertical asymptote. Okay, how about horizontal asymptote? Yeah, I mean, they're both second degree, right? It's 2 over 1, 2. So it should be a horizontal line going like this. Okay, and anything else? That's all we've got now. So by the table of values, we would need to fill in. We need to be filling in some points to the left of this vertical asymptote, in between the two, and then to the right. There'll be 3 different parts of the graph. So I would say on this side, we already have this point. We could pick a couple more in here. Let's say negative, what is that? Negative 4 and negative 5. That would probably give us the kind of shape that we're looking for. Negative 4, negative 5. Let's try x and y. Negative 4, negative 5. And look for this middle part. That's the only point that we've got. So we should do like 1 point in between that point and the vertical asymptote. How about negative 1 and positive 1? And then over here, we got the same, pretty much the same situation as we have on this side. So let's pick, like we picked negative 4 and 5, how about 4 and 5? Okay, now, that's example 4, right? I think it's down here. That is example 1, example 4. Okay, so let's go to the table of values with this thing. And we're going to do negative 4. Oh, that was negative 5. That's okay. Negative 4, negative 1, 1, 4, and 5. Okay. Wow. So that one, you know, as far as our accuracy here, I'm going to just round it to the 10th. You know, I can't be that accurate anyway. So how about negative 5 and positive 5 were both 1.5. And if I go back, let's see, negative 4 and positive 4 were 1.2. And negative 1 and positive 1 are about 5.3. 0.3. Which means that's going to be like off the scale. It's a little bit farther up than I can show, but that's okay. We'll put it there and there. So the middle piece looks something like that. Right, these pieces, 1.5, 2, 3, 4, 5. 1.5 is about there. 1.2 is about there. So there's the 3 points. We can kind of see how they're shaped. And we know that that's angling off towards the asymptotes. The other side is just the same thing. So this is 1.2, 1.5. There we go. Okay, now if I look in the graph, since, try this, zoom 6. Okay, try that again, graph. It shouldn't be stopping right there. I think it's got an issue. There we go. So that looks pretty close to what we got there. Now, you remember, what kind of a function is it that looks the same to the right of the y-axis as it does to the left? Say again? Can't hear you. It's even. That's what an even function looks like. Remember how you tell an even function looking at it? Everything in it is squared or raised to an even power or a constant. So, in fact, if you look at the directions for these, they say use symmetry. In this case, we could have said, you know what? I don't need to graph both sides. I can just graph one side, and I know it's identical on the other side because it's even.